Now, it's okay to cover this with slides and theory. You're going to learn much more, however, if you do this yourself. So make sure that you download the packet tracer file and have a look at this. In this example, I've got this laptop, and I could open up a web browser to the server. Server IP address is 192.168.1.3. So I'll browse to 192.168.1.3 and click Go, and a web page is displayed. What I'll do now is click on simulation mode. Make sure that you've edited your filters. So click Show All None. So make sure that you see none here, and then click Edit Filters and only show HTTP. So that's the only protocol we want to view at the moment. And now on the laptop, I'm going to click Image Page and click Next. And what we should see is something is sent into the network. Here's a packet sent into the network. The important part that we're going to focus on here are the PDUs. So let's have a look at inbound PDU details. What you'll notice is destination MAC address is a bunch of 3s. That's because I configured the server with that MAC address. Source MAC address is 0s and 1s. Again, I manually changed the laptop to use that MAC address. So this is a frame. This is layer 2. Notice Ethernet 2. At layer 2, we're using Ethernet. It's an Ethernet cable physically, but at layer 2, we've got an encapsulation called Ethernet 2. You're going to see that a lot. Notice here, type field. How does layer 2 indicate that it's a layer 3 protocol? Type field. 800 here means IP version 4. You can search for the various types on Google. This is just an article on Wikipedia showing you the Ethernet type for various protocols right at the top here. IP version 4. 0806 is ARP. These are hexadecimal values. If you see 0x, it means hexadecimal. Whole bunch of protocols. Apple Talk is something we used in the old days. IPX I've mentioned a few times. So at layer 2, it needs to indicate which protocol is used at layer 3. That's based on the type field. I could just search, for example, for IPv6. Notice there, 86DD is the type field for IP version 6, but this is IP version 4. So it's 0x0800 hexadecimal value. Make this bigger so it's easier to read. There you go, per the information on Wikipedia. Okay, so at layer 3, the protocol used is IP version 4. So source IP address, destination IP address. What at layer 3 indicates the protocol at layer 4? It's the protocol field. Protocol field indicates that we're using TCP at layer 4. Now the IANA, or Internet Assigned Numbers Authority, has a list of protocol numbers. They determine the protocol numbers for various protocols. So as an example, if we scroll down here, notice 6 is TCP, and then they tell us the RFC for that protocol. Scroll down a bit further, we've got UDP, RFC over here. Notice, however, that there are many other types of protocols. It's not just TCP and UDP. We've also got ICMP listed here. We've got EGP, which is an older routing protocol which we no longer use. We've also got IGP, another old routing protocol. I won't bore you with any others. The big ones are TCP and UDP. Notice this is TCP 6. UDP is 17. So the computer knows that at layer 3, the protocol is IP version 4. The protocol at layer 4 is TCP. So hence we see TCP here. We see source and destination port numbers. The port number determines the application at layer 7. 80 is the famous port number. So notice we've got an HTTP request. And here we can see the data for that HTTP request. So the client is basically requesting information from the server. What I want you to also note is the source port and destination port. There are various types of port numbers. And again, the Internet Assigned Numbers Authority, or IANA, has a list of port numbers. What's important to realize is there are 3 ranges of port numbers. We have system ports, also known as well-known ports. They are from 0 to 1023. We have user ports, which are in the range 1024 to 49151. And then we have dynamic or private or ephemeral, different terms used for the same thing, port numbers in this range. Now remember, networking has been around for a long time. Things do change. So the port numbers that devices use will change. What you need to know are some of the well-known port numbers, and just be aware that anything greater than 1023 is probably going to be a dynamic or ephemeral port number. Newer devices actually use this range, and I'll show you that on the physical computers. But notice on Packet Tracer, the port number used here as the source port is 1026. That's because it's greater than 1023. This is a random or dynamic or ephemeral port number that's used by the client so that when traffic comes back from the server, the computer knows to send it to this client application, so your web browser. When you open up a web browser and you open up multiple sessions, it could be using different port numbers so that the traffic that arrives back goes to the right window or right application. As an example, you may open Chrome and then you may open Firefox, two browsers using HTTP. When traffic arrives, how does it know whether this traffic goes to the Chrome browser or this traffic goes to the Firefox browser based on port numbers? Okay, so the traffic now gets sent to the server. So I'll play that to the server. What happens when the server replies? What you'll see is the source and destination MAC addresses are swapped around because the communication is now from server to client. So it makes sense that the MAC addresses are swapped around. How does it know which protocol is used at layer 3? Type 800, telling us that this is IP version 4. Source and destination IP addresses are also swapped around because the traffic is being sent from the server 192.168.1.3 to the client 192.168.1.1. How does it know which protocol is used at layer 4? That's based on protocol number. Notice protocol number 6. So we have TCP here. And notice the port numbers are swapped round. It's the same port numbers. They just swap around now because the traffic is coming from the server on port 80 going to the PC on port 1026. The client randomly chose the port number for that session. Should be random, not always, but should be random for the session. How does it know what application is being used? Because of this randomly chosen port number, the client will allocate that port number to the application. So when it hits the computer now, the computer knows which layer belongs where. Here's a nice summary. Protocol at layer 7. Notice they're talking about layer 7, even though this is a 5-layer TCP IP stack. Layer 1. Physical port on the computer. That's the network interface card that receives the traffic. Ethernet 2 is the encapsulation at layer 2. The traffic is from the server to the client. At layer 3, we have an IP header, IP source address, IP destination address, which are correct. Source port number is 80, destination port number is 1026. We see that really nicely there. Notice application is HTTP. There's no 5 and 6. So on the inbound PDU, we see this in more detail. Destination is the PC, source is the server. Type field is telling us that it's IP version 4. Source is server, destination is client. Protocol at layer 4 is TCP. Here we see TCP. We can see a whole bunch of information, but notice source port is the server replying to the client application that has been given 1026 as the port number. Now what's doing that is the operating system. So Windows, as an example, will allocate that. Here's the response to the request for information. So the server is sending some information to the client. And if we keep on playing that, notice the traffic has arrived at the client and we can see part of the website, but there's probably more data. So if we continue through this, you'll see the message sent to the server, the inbound message, is the client 192.168.1.1 asking the server for something. So we scroll all the way down, you can see there's an HTTP request. It's requesting something from the server. And on the outbound, this is going back now, the server is replying. So the destination is the PC, source is the server. And if we scroll all the way down, there's some data sent back to the client. So we will notice a whole bunch of messages being sent between the client and the server. As an example, here's another message giving some data back to the client again, but I'll put this back to real time. And when we go to the client now, we see the Cisco logo displayed on the client. Okay, so remember we have a sender and a receiver. In our example, the client, let's say, is sending traffic to the server. It's going to pick a port number, random port number 1026 to port 80. That's because we're using a web browser such as Firefox or Chrome. The web server listens on port 80. These are defaults. Obviously, in today's world, we use encryption, but we'll just keep it simple for the moment. So Chrome or whatever your browser is sending traffic into the network. You open up the browser, you type in a URL such as google.com. That kind of information is then sent into the network. So the application is sending data to layer 4. What's actually doing this physically is your operating system. So we as users are abstracted from the nitty-gritty or the details. We just simply open up a web browser. But the operating system like Windows or iOS on a phone or Android on a phone is doing all of this. So the data sent to layer full, that's then sent to layer 3. But remember, at each layer there's encapsulation. Sent to layer 2 and then transmitted across the wire as bits. This is a segment, this is a packet, this is a frame. These are bits transmitted across the wire. So we have encapsulation on the sender and de-encapsulation on the receiver. So headers are added at each layer. Layer 4, layer 3, layer 2, and then data is transmitted. When it gets to the receiver, receiving the data, remember this could be pulses of light on a fiber cable or could be electrical signals on a copper cable. The network interface card is receiving that. It's reading the frame and then sending it to the correct protocol stack, which could be IP version 4, IP version 6, then goes to, say, TCP or UDP, then goes to the actual application. So encapsulation, de-encapsulation. What's happening is each layer is communicating with the same layer on the other side. So as an example, we've got HTTP here talking to HTTP here. We've got TCP here talking to TCP here. We've got IP version 4 talking to IP version 4. We've got Ethernet 2 talking to Ethernet 2. And then the actual transmission is electrical signals or pulses of light as an example.